Hi everyone, welcome back. Today's video is going to be about scientific notation, and I want to talk about the format of scientific notation and how the math works with it. Now, I know when you first saw scientific notation, maybe like me you thought, oh boy, I'm in for it now. But it's actually a really helpful and really useful notation for really large or really small numbers. So like if you took Avogadro's number, so you could write it in scientific notation like this, or you could write it in standard notation like this. And you can see really easily that writing out all those zeros at the end becomes really cumbersome for you as the writer, or as the reader, it's really hard to digest what that number really means when it's not in scientific notation. With that being said, and hopefully a little encouragement, let's take a look at my examples. Okay, so here I've got 4 examples of scientific notation, and the first thing I want you to look at is the first part of each number here. Now notice that there is only one non-zero digit to the left of the decimal place. So when you're talking about scientific notation, you're always just going to have one non-zero digit to the left of the decimal place. Now if you look to the right of the decimal place, you get a lot more freedom to the right of the decimal place. So you can see here in this last example I have a 0. That's perfectly fine to do zeros. Your scientific notation should reflect how many sig figs you need in a number. So say for example I were to go back to this second example and I'm thinking, oh no, I only have 2 sig figs, I really need 3. That's really easy to fix. You just put a 0 right there, and now you have 3 sig figs in that scientific notation. Okay, let's switch up to magenta, and let's talk about the second half of scientific notation. So obviously you can see that it's always times 10 raised to some power. Now this power is always going to be an integer, so we won't have to deal with decimals or fractions. However, with integers, we can have positive or negative integers. So you can see here I have an 8 and here I have a negative 2. So let's break down this second half of scientific notation just a little bit more. All right, I'm going to go back to blue. So if you were to just see 10 squared somewhere, you would think 100 and you wouldn't even worry about it. So if I'm taking my scientific notation here and I have 6.53 times 10 squared, or 10 to the second, all this means is I want to multiply my 6.53 times 100. That's just going to move the decimal place 2 places to the right. So if I were to take this out of scientific notation, it would be 653. Easy, right? Okay, so if I had 10 cubed, or 10 to the third, again, that's just 1,000. You guys already know this. It's just 1,000. Sometimes when it's coupled with something else, it can look confusing. So if I take my same number, my 6.53, and suddenly I'm raising it to the third, I'm just moving the decimal to the right one more place. That's going to make 6,530. No problem. Okay, let's take a look at negative exponents. All right, so here we've got not 10 squared, but 10 to the negative 2. So remembering back to all those math classes, remember when you have a negative exponent, all it means is you're taking the inverse of that number. So you can see that instead of multiplying by 100, I'm going to divide by 100. That's just going to switch the decimal place again, but instead of moving it to the right, we are going to move to the left 2 places. So my answer here is 0.0653. Now, one thing I do want to point out, so you'll notice that people who write numbers a lot, when there's nothing in the ones place, they are always going to put a 0, and what that does is it makes this decimal point much easier to see. So I'll just put that as an aside. When you're writing decimal points and you don't have anything in the ones place, it's really helpful to put a 0 here. Then your reader can find that decimal place really easy. Okay, that was my little mini lesson in there. Let's go back to now 10 to the negative third. Again, it's just the inverse, so we're dividing by 1,000. So I just need to move that decimal one more place to the left. 0.00653. And that's it. So I hope you found this video helpful, and maybe it helps break down scientific notation a little bit more. Later videos, we're going to deal with converting numbers into scientific notation and out of scientific notation. I know we did that a little bit here, but I want to give you some more examples on how to do that. Thanks very much for watching.